Are we already recording, or am I recording now?
No.
No. All right, so welcome to Friday, December 16th. I'm so sorry I wasn't here with you yesterday, but again, if you could please secure your devices, that means all electronic devices, put them away, all AirPods, earbuds, everything like that. We have it just seems like so many people are sick in the school, it's just crazy. If you could write down our daily question, it says, what was discovered on the bottom of the Atlantic Ocean during World War II while searching for enemy submarines? This was one of the questions that were on one of the little videos that we watched after reconstructing Pangaea. Remember, we had Alfred Wegener, and he had this idea of continental drift, and this was something that helped to give evidence towards that. So what was it? Today, students are going to investigate how plate tectonics operating over geologic time has changed the patterns of land, sea, and mountains on Earth's surface. How are we going to do that? Students will construct a model of the ocean floor and record data using appropriate graphic representations, including charts, graphs, and label diagrams, and make inferences based on that data. I want to let you know you have your quiz today after our capture question. It's just a 4-point check for understanding. It's going to be great. And then we're going to be doing an activity called charting the ocean floor. Fabulous. There is Liberty Time today, so if anybody needs to come in and work with Mrs. McGrain, let me know and I'll write you a pass. I'm now going to be quiet for a minute so that you can go ahead and write down, your daily capture question, and I can take attendance. I should probably put a minute then on the clock. No Hassan today? If anybody has their essay to turn into me, I'd love to take that. I'm going to start grading those today. All right, we got 15 seconds, and then we'll go ahead and share out. Five, 4, 3, 2, and we are done. All right, let's go ahead and talk about this. Actually, how about this? Turn with your pair share partner, and for 10 seconds, let's go ahead and just share that out. I'll give you 15 seconds. On your marks, get set, go. What they find on the bottom of the sea floor? All right, let's go ahead and share that out. Michaela or William, would you mind turning that a little bit? What they find on the bottom of the sea floor, y'all? What they find on the bottom of the sea floor using sonar? Yep.
Underwater ridges.
Yeah, they found what was called a mid-ocean ridge. Can anybody tell me what was this mid-ocean ridge? What was it made of? William.
Rock.
Can someone tell me what was this mid-ocean ridge made of? Yeah.
Volcano.
Yeah, it was a mountain range of volcanoes. Mountain range of volcanoes. Why was it called Mid-Ocean Ridge? Asa, I'm asking you. Mid means what? It's the middle of the ocean. It was in the middle of the ocean. This mid-ocean ridge gave evidence to what? Yeah, evidence of Wegener's theory of continental continental drift. He said, hey, I think these continents are drifting, are moving. He showed evidence, but he didn't understand why it was happening. This gave evidence to show, wow, you know what? He's right. Because in the center, we're going to go ahead and just draw ourselves a little picture on this. And I'll put the water up here. And this is the crust. And this is the mantle down here below the crust. And we've got convection currents. Let's say we've got convection currents moving in this direction. It's showing that the land was splitting and there was these mountain ranges that were running along as the magma was coming up. It was filling the gap as that land was then moving apart. So you've got this magma that's kind of flowing. It's hitting this cool water, so it hardens. And then as these currents, these convection currents, pull this land apart some more, it cracks that crust, and then more magma comes up and oozes out. And so you get these mountain ranges that were built at the bottom of the ocean. It's kind of like if you have a cut on your hand and blood comes up, that's like the magma, and then you get a scab. That scab is what's formed at the bottom of the ocean. And then that scab opens up and more blood comes out and hardens again. That's what's happening at the bottom of the ocean. There's just this kind of like long, scabby scar that's at the bottom of the ocean. Today, we're going to go ahead and chart that. We're going to go ahead and look at that using depth, sounding depth. Do you know what sonar is? Okay. Do you know what an ultrasound is? Okay, an ultrasound is meaning that they, in a mommy's uterus, they send sound waves in and it bounces off the baby and it makes kind of like an echo picture. That's what they did at the bottom of the sea floor to find out that there were these long volcano chains. They were looking for submarines, but they found out that there was some weird thing going on at the bottom of the ocean that they didn't know about. All right, so first though, we're gonna go ahead and take a little 4-point quiz, just a little check for understanding. It's gonna be great. Yes, it is. Just stop it. If everyone put your things away, I would greatly appreciate it. We're going to just go ahead and see what our understanding is, and then don't worry, there will always be some retakes if you need to go ahead and retake. I've got 3 different quizzes in here so that you don't all have the same quiz sitting next to each other. So I'm going to go ahead and give that to you. If you could please make sure that your eyes are on your own paper, and when you're done, just bring them up and flip them upside down. That would be super great. Did you scooch in for me, bud? Thanks. You're the best. Don't tell all of the other people in here that I think about.
Hello, people at home.
Hey, thank you. No, just a quiz. Thanks. Thanks for checking with your names on it. Thanks. charting the ocean floor, that would be great. Thanks, Kylie. You're excused. All right, my little buttercups. Let's go ahead and look at what we're doing on this. So we're going to go ahead and follow the footsteps of the World War II people when they were going ahead and using sonar technology. How do scientists know how deep the ocean is? Well, a long time ago, the depth of the ocean bottom was measured by sending down a long rope with different knots at different, that's what these equally spaced marks were on it. And they'd do it by fathoms. It's so many fathoms deep, right? And then they'd have to, bring up all of this rope. The number of marks that had gone into the water was then counted. It wasn't very accurate, but it did provide some idea of ocean depth. Now the most common way to measure ocean depth is by using sonar technology. Sonar stands for sound, navigation, and ranging. This is mounted on ships like this. And what they do is they send down a sound wave and it bounces off of the floor and it comes back up. And they look at the time it takes for the sound wave to go down and back, like an echo, and they determine a certain distance with that. What's up, bud? Kind of like echolocation, that's right. And so originally they were looking for submarines, right? Like if a submarine was right here, it would be able to bounce off of that and it would show like as this symbol. Anybody in here fish? Fish finders do the same thing. They send down sound waves and you can kind of look for schools of fish. Okay, so these instruments send a sound wave from the surface of the water down to the bottom of the ocean where it then bounces back to the ship. Scientists measure the time it takes for the sound wave to be transmitted down to the ocean floor and back to the surface. Because we know the speed of a sound wave through water, we know how fast sound travels through water, we can then use this information, meaning the time it takes for the sound wave to get to the ocean floor and back, to then calculate the depth of the ocean floor at different locations. Below in this data table is a depth data for the Atlantic Ocean that was generated using sonar technology. We're going to follow the directions on the back of this chart to make a profile of the depth of the Atlantic Ocean. By examining the depth of different areas of the ocean, we will map the Mid-Atlantic Ridge and other features of the ocean floor, like the continental shelf and deep ocean trenches, okay? So what I've done for you on this is I've made this a piece of paper that you can rip open and you can have half of this paper, so there's nothing on the back of this, so you can rip this apart if you want and put it next to our graph so that we are going to need to be graphing so you don't have to keep flipping back and forth. All right, let's go ahead and look at this graph so that you know how this graph is set up and you can kind of quickly get through this. Okay, the first thing is I want you to know that this goes down in depth. So this top line at the top at 0, that's the top of the ocean. So that's the surface of the ocean. And then this is 1,000 meters below the surface, 2,000 meters below the surface. And that's separated by 100-degree marks. So this is 0, and then this would be 100. Come on, pen. Oh, fine. Come on. So that's 100. If you need to go ahead and separate these or write some little lines in there, go ahead now if you have to use the restroom. Somebody asked me to go to the bathroom. Come on, pen. All right, so I'll just go ahead and write this in for you. This is 100. This is 200, so if you need to write that in for yourself, you can definitely go ahead and do that. This is 300, and so it goes 100, 200, 300, 400, 500, 600, 700, 800, 900, and then 1,000. What are you looking for, bud? You did that and I didn't read that. Did you from yesterday? The essay? Okay, and so then that's how that works is these are 100 marks in between here. Now along the bottom, this is the longitude that we're looking at. And so this is 0 longitude, and then it goes 2, 4, 6, 8, 10. And so if you need to mark those off, I want to let you know that these go by 2s. So now what you're doing is you're graphing. So then I can go ahead and do the first one with you. The first one I believe is 0 longitude, no, I'm sorry, 0 ocean depth and 64 degrees longitude. So if I could get my pen working, that'd be super great. Oh, there we go. Oh, I have to hit it. So then I go 0 depth, 64, so that's 60, 62, 64. So my first dot is gonna be right there at 0 depth. And then my next one, sorry, mine does not all fit on the paper. I can try to make it small so I can fit it on the paper. Okay. It's teeny tiny. Oops. If anybody needs help, let me know and I can come over. I've given you those little rulers or purple pieces of paper so that it'll help you kind of figure out where your lines are. If you want. All right.
Sorry, my lines aren't straight. So it should look something like that. And then we color. Write and color it up or label it. You've got directions on the back sheet. On the back, yep. Coloring all of the ocean water blue. And then the crust is gonna be brown. I'm gonna label the continental shelves. And what else? Continental slope. Why do you think they call it a continental slope? What do you think, Brady?
Because it slopes down.
Yeah, from the what? The
That's right.
continent, yeah, the continent. So it's the continental slope because it's sloping down from the continent into the bottom of the ocean. There's two of them, one on either side. And then we have to label the deepest trench, so I'm gonna go ahead and label this trench. Trench is where we're gonna see one part of the crust diving below another part of the crust. I'm gonna label the Midocean Ridge, or the Mid-Atlantic Ridge, I guess. What other things do they want us to label? Oh, one of these things is Europe and one of these things is North America. I think this is Europe. Wait. Wouldn't that be Europe? Europe is over there. So this is Europe over here. And this is North America. Yay. Oops. That's what it should look like, roughly. So you've got the crust and you've got the water, you know, that's like inside that big depression. And you clearly see the Mid-Atlantic Ridge in this kind of relief form. Does yours look kind of like that? Great. Good coloring, man. Just make sure they're labeled and then answer the questions. It says, what are the approximate longitudes of the oldest part of the crust shown in the diagram? So if this is showing that the land is moving apart, right? This land's moving in this direction, this is moving in this direction, cracking this open and like forming this ridge. What then is the oldest part? If we were to reverse it back and put together Europe and North America, where's the oldest longitudes? Where's the oldest part of the crust? Would the oldest part of the crust be here? Would the oldest part of the crust be here? Here? Where do we think the oldest parts of the crust are? Are they in the middle? How about this? Where's the brand new crust being made? What? Not the edges. The brand new crust is coming up through here, and there's this big crack right through here, and the magma is kind of like spilling out and over. So the newest crust is here. This is the newest, brand new crust is right here. So then the oldest crust has to be away from that, farthest away from that on the edges. So this is going to be old crust, and this is going to be old crust over here. So that's where the old stuff is, on the edges. So find your latitude or longitudes and go ahead and write that in. So it says, what's the approximate longitude of the newest part of the crust? What's the longitude of the newest part of the crust? About 30? Yeah, like 30. Approximately 30 would be like our newest. Would be like in this general area. Right, where it's splitting. .30 west, I think that is. The Mid-Atlantic Ridge occurs at the plate boundary between two of Earth's crustal plates. Do we know what type of, which boundary type it is? You might not have this information yet. Do you know what the boundary is when two plates are like moving away from each other? We'll look at that on Monday. How about number 7? What's the relationship between the age of the rocks on the ocean floor and their distance from the Midocean Ridge? As the rocks get further from the Midocean Ridge, what happens to the age of rocks? They get older. They get older. As we move farther away from the Mid-Atlantic Ridge equals older rocks. And we've dated them, and that's true. And now it says just name 2 pieces of evidence that seafloor spreading and continental drift occur. So work yourselves through that. William, am I going to get any work from you? So my peeps at home, we graphed. We're answering questions on the graph. Monday, we look at maps.